Problem B. A function f has a Maclaurin series given by 1 plus x squared over 2 factorial plus x to the 4th over 4 factorial plus x to the 6th over 6 factorial, and so on, with a general term of x to the 2n over 2n factorial. Which of the following is an expression for f? A cosine x, B e to the x minus sine x, C e to the x plus sine x, D 1/2 e to the x plus e to the negative x, or e to the x squared. So for this we need to know some commonly known Maclaurin series. The first one is cosine x, which is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on, which has a similar general term as the function f, except that it has an alternating component. Because of this alternating component, we know that A is not the correct answer. For sine x, we have x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, and so on, with a general term of negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. And lastly, we have e to the x, which is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial, and so on, with a general term of x to the n over n factorial. And like I said, cosine x from option A does not match the function f, so we know that option A is incorrect. For the other answer choices, the terms of the series must be added or subtracted based on the signs in the answer choices. For example, to make the Maclaurin series for answer B involves subtracting the terms from the sine x series of subtracting them from the e to the x series. So for option B, we take our e to the x series, 1 plus x squared over 2 factorial plus cubed over 3 factorial, and so on, and subtract the sine series, x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and so on. When you add these terms together, you keep the 1 from the e to the x series, the positive x from the e to the x, and the minus the positive x from the sine x cancel out and give you 0x. Then you have the x squared over 2 factorial from the e to the x series, and the x cubed over 3 factorial from the e to the x series, and then minus a negative x cubed over 3 factorial from the sine series. This is going to cause a problem because now we have 2 of the x cubed over 3 factorials in answer choice B, whereas in the Maclaurin series given for function f, there are none. Because of this, we know that B is incorrect. Mistakes here can occur with mixing up negatives and not distributing the subtraction sign, so make sure to use parentheses. Similarly, for answer choice C, we add, this time, the components of the e to the x and sine x series. So for answer choice E, we have 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on, and add x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and so on, which gives us 1 plus x from the e to the x series plus an x from the sine x series plus x squared over 2 factorial from e to the x and an x cubed over 3 factorial from e to the x minus x cubed over 3 factorial from the sine series, and so on. Here we see that for option C, we have 1 plus 2x plus x squared over 2 factorial, and so on. We know this answer choice is incorrect because there is no 2x in the function f. For answer choices D and E, we have to replace the x's in the components of e to the x to give ourselves e to the x and e to the x squared and e to the negative x. So we have our equation for e to the x, 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus ... until you get x to the n over n factorial. To make e to the x squared, we replace each x with an x squared. So now we have 1 plus x squared plus x to the 4th over 2 factorial plus x to the 6th over 3 factorial, and so on, and we have x to the 2n over n factorial. Answer choice E is e to the x squared, which does not match f because the denominators are incorrect. mistakes here can happen because after you get used to writing so many Maclaurin series, you may start to have the denominator match the exponent, and here you have to be very careful so that you realize that x to the 6th is not over 6 factorial, and x to the 4th is not over 4 factorial, and so on. Okay, so by process of elimination, we know that answer choice D is correct, but for the sake of math, and because Goodman told me to, here's why. So when we create the e to the negative x series, then we replace all the x's of the e to the x series with a negative x. So it's 1 minus x plus negative x squared over 2 factorial, and so on and so forth, all the way through. When you square a negative term, it becomes positive because you have a negative times a negative. So when you rewrite the e to the negative x series, you have 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial, and so on and so forth. So for answer choice D, we have 1 half e to the x plus e to the negative x in parentheses. So to do this, we leave the 1 half on the outside and put the e to the x and e to the negative x components added together. So we have 1 plus x squared over 2 factorial, and so on from e to the x plus 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial, and so on from the e to the negative x series. On the inside of the parentheses, this gives us 1 plus x minus x plus x squared over 2 factorial plus x squared over 2 factorial plus x cubed over 3 factorial minus x cubed over 3 factorial, and so on, so that the even power terms, including x to the 0, will remain inside the parentheses, and the odd terms will cancel due to subtraction. So you have 1 half of 2 plus 2 x squared over 2 factorial plus 2 x to the 4th over 4 factorial, so on and so forth. When you distribute the 1 half, you have 1 plus x squared over 2 factorial plus x to the 4th over 4 factorial, and so on, with the general term of x to the 2n over 2n factorial, giving us the correct answer of D.